Okay, so we're going to start today just briefly getting into 1.7, which is modeling with functions. Okay, so basically we're going to be creating equations to model different situations, and we're going to take known equations that you guys have from like geometry and some other stuff like that, and try and produce some new ones using substitutions to help us out. So I want to start with an example here, and we're going to engage your memory here a little bit. Area of a circle. What's the formula for the area of a circle? Yeah. Nope. That's the circumference. Yes. Pi r squared is the area. Yeah. So you have seen this formula before. Okay. But actually that is just one equation for the area of a circle. I can make all sorts of equations for the area of a circle. It all depends on what is it a function of. Okay? So this particular area of a circle equation, what is it a function of? R, the radius, right? So technically, if I'm going to use this as my area of a circle equation, it would be A of R equals pi r squared. Area of a circle as a function of its radius is what that is. So let's say I wanted to create another equation for the area of a circle, but I wasn't interested in using the radius. I wanted to use the diameter. Okay, so the diameter of a circle, someone actually already mentioned this one, it's 2 pi r. So if I want the area as a function of diameter, how could I take this information and do that? Knowing that this is the area as a function of the radius, and the diameter, oh, I'm sorry, that's circumference. Oh my good lord. Sorry. You're probably like, wait, what? That's not right. Okay, 2r, right? Yeah, I'm stupid. So d equals 2r. So let's try this again. So area of a circle, pi r squared using r, but diameter is equal to 2 times r, so how could I then create an equation for the area using d instead of r and all that information? Yeah, Josh.
Couldn't you set up like the diameter so that it equals r?
Okay, so we're doing a substitution with the r, so I'm going to have to work with this a little bit first technically before I can do that, right? So I need to solve that for r, which would be r equals d over 2. And so now I can take my known equation, pi r squared, and do a substitution for r, put in a d over 2 instead of r, and then simplify that up as far as I can, and that would be my new equation involving d. So I'd have pi times d over 2 squared. And we can simplify that up just a little bit. If we have a fraction and we're squaring a fraction, how do we do that? Square the top, square the bottom. Okay? So this is pi times d squared over 4. And then just because it's kind of a more accepted way to write it, since pi is technically a number, I could take the pi and the 4, make it a fraction, and then the d squared can come off the 4. So kind of the cleanest looking version of this would be pi over 4 d squared. So now I have an equation for the area of a circle that works, but it's nothing like you've seen before. Okay, now it's if I want to know the area of a circle and I have a diameter to plug in, I can use that equation then. Okay, so let's try this one more time. Now we're going to use the circumference. Okay, so again, we'll come back to where we were at, a of r equals pi r squared, and then we know the circumference of a circle is 2 pi r. So see if you can do the same kind of thing here as we did with the diameter. And now I want my area as a function of the circumference of the circle. Okay, so take a couple minutes. See if you can repeat that process now, but make it a function of c instead of a function of d. All right, anybody need more time with that? All right, I'm going to unfreeze here, show you what I have, and see if it's what you have. Now, I did some simplifying here too. So the substitution is the key step, but we'll work on the simplifying a little bit as well. But I ended up with c squared divided by 4 pi. Okay, so first thing, r is equal to c over 2 pi. Okay, that's what we're going to substitute in this time because we have an equation involving r, so we can substitute that piece in. So we got pi times c over 2 pi squared, because that's our r. Yeah?
How would it become c over 2 pi?
I divided each side of this equation right here by 2 pi, because I had to solve it for r. So you got to divide by the 2 and the pi, so I just did it at the same time. Okay, and then here's my substitution step. Okay, pi r squared, but it's that c over 2 pi. And then I squared that fraction, so c squared. The 2 and the pi both get squared, so it's 4 pi squared. But then I noticed that I had this pi out front that would cancel one of those pi's. So it was c squared over 4 pi. Okay, and that would be your area of a circle equation in terms of the circumference. So as a function of the circumference. Okay. Yeah, I'm going to do another one that's not using circles, but similar to the same kind of thing. Yep. The next one we're going to look at is actually a cone. I think this one's a little simpler, actually. But if you don't remember the volume formula of a cone,